Hello guys, welcome back to Java Devs channel. Today we're going to be looking at some interesting code snippet on OOP, and we're going to be using instance of operator to test your OOP skills. So be prepared guys, it's going to be an interesting session which is also going to be interactive. I'll be asking you guys some questions. So as you can see, we are going to use Notepad++ because we don't want to rely on an IDE to tell us whether the code will compile or not. We have to make those deductions ourselves because now we are compilers, and I will be using command line to compile and run the code accordingly. So guys, without further ado, let's get cracking. I'm gonna start with this setup guys, extends edu. So if I was to ask you whether this code compiles, you will definitely say yes, it compiles. Why? Because we see there's a relationship between edu and cat, because cat extends edu. So obviously cat is an instance of edu because of that relationship. But if cat and edu were not related in the inheritance hierarchy, the compiler will definitely compile it because there is no relationship between the two. So let's compile this code guys. So we're going to say Java C. Okay, let me just increase Java C main.java. Sorry. Okay, compile successfully. So if we run it main, we get true because there's a relationship between these two. Now let's do something a little bit different. We're gonna remove this relationship. So if I ask you whether this code will compile, you will definitely say no. Why? Because this time around there's no relationship. So let's quickly affirm or certify our claim. So we're gonna try to compile this code, and wow, it doesn't compile because these two things are not compatible. Okay, let's change this code a little bit now. It was initially edu as a class, but now let's make edu to be an interface without changing anything else. So now the question is, will this code compile? And I know you probably said, no, it doesn't compile. And if you said it doesn't compile, I'm afraid you are not correct. Wait a minute. What's going on now here? Because there is no relationship between class cat and interface edu. So what's going on here? So what you need to know from today is that the compiler will not report an error when using instance of with, the compiler will only report an error when using an instance of operator with unrelated classes, but it has a limited ability to do so with interfaces. So this code, of course, it compiles. Okay, let's see if it compiles. Yes, it compiles this time around. So, wow, it does compile. But now the question is, if it does compile as we have seen, what does it print? It has to print false because the actual object returned here is not compatible with edu. So let's run it and see. It prints false. Now another million-dollar question is why now does the compiler not complain, and yet it complains? Why does the compiler not complain with interface, and yet it complains with classes? Now we want to find out why does it not. So to answer this question, we want to ask ourselves another question, and that question is it possible to have a subclass of cat that implements edu? And the answer is yes. While we are still on that note, we should know that although we have this line of code here, cat equals to new cat, the compiler will only know at runtime the actual type of the object that reference cat point to. It doesn't know at this time, at compile time, that this is cat. I will give an illustration for that shortly. It only knows at runtime that object that reference cat point to is actually of cat, is an object of type cat. So let me show you another code snippet to illustrate that. Then I will give another illustration. So assuming we have this kind of this code snippet, we have list. In this case, we do not know what type is returned here. We will only know at runtime the actual type that is returned. But what we do know for sure is that the actual type is in the inheritance hierarchy with iterable number. It's actually compatible with it. Okay, let me make an example. Let's say this time around cats implement edu. Then we also have lion implements edu. I'm gonna remove this code for now. We're going to have a public static edu get, just a get method that takes a string as a parameter. Then we're gonna have if st dot equals to cat, let's say cat, let's say return new cat, else return new lion. If I say edu equals to get cat, I can assure you that this scenario here that we have, the compiler does know that what cat returns is compatible with edu, or we can say it's in the inheritance hierarchy with edu, but it does not know the actual object at compile time that will be returned. So in this case, we are passing cat, which means we're gonna get cat as an object. If we pass something else, maybe lion, obviously we're going to get this one returned. But at compile time, the compiler does not know what the returned object would be. So that is the concept we are trying to illustrate. So let me undo and get back to our initial code design. So now, to illustrate what we said it is possible to have a subclass of cat that implements edu. So I'm gonna do this, and I'm gonna remove this to return to where it is. subclass cat. So we're gonna have lion extends cat and implements edit. So this is the scenario that we have. So in that case, we can put lion here. So if we compile this code and run it this time around, we are going to get true. Why? Because the type that is returned here is in the inheritance hierarchy with edu, in the sense that it implements edu. And while it also extends cat, that is what we were trying to explain. So as we can see, lion extends cat and implements edu. So since the compiler does not know the type, as we have mentioned, of the object that cat points to at compile time, also given that we can have subclasses of cat that implements edu, now it should make sense why the code that we had before compiles. So now this tells us how smart the compiler is. Yeah, the developers of the compilers are really smart. So based on the code before, the compiler is basically saying, so that means when I say based on the code before, I mean this code. This is what I mean. So based on the code before, the compiler is saying, I do not have sufficient information to make a ruling as to whether the type is compatible or not. But on the other hand, I cannot rule out the possibility. Hence, the compiler now says, I adjourn the verdict. I cannot make any verdict. We can only depend on the JVM now to give us or to tell us at runtime what's going to be. So now I want us guys to tweak our code a little bit again. So now we for now, if we say compile, it does compile. So now we're going to make our class final, which is cat. So now if I ask you, will this code compile? You probably said yes, it compiles. Ish. I'm sorry, you are wrong again. This time around, cat is final, which implies it is not possible to have a subclass of cat that implements edu. So the compiler here is smart enough to see the code has a fundamental problem, hence it will not compile. So what does the compiler say? The compiler is saying, although I do not know the actual type that cat points to at compile time, I know it is not possible that cat and edu can have a relationship because cat is final. So I can right away give my own verdict that cat will never be compatible with edu. Then the compiler complains. So let's run this code, let's compile this code and see that it will not compile. Indeed, it does not compile. Wow, this is interesting stuff. So guys, as we complete, let's go back to the previous scenario that we had. So I'm gonna remove this and leave this as this. So if we are to compile this code, definitely it's not going to compile because these two classes do not have a relationship. So now let's explain it based on the information that we already have. We see that in this case, it is not possible for us. We see that class edu and class cow are not related in any way, and that's straightforward. Again, it is not possible to have a class that extends from cow as well as edu because of single class inheritance. we do not have multiple inheritance in Java. So in this case, it makes sense now to understand why this for interface works, but for a class it doesn't work, because of that multiple inheritance problem that leads, because of multiple inheritance that leads to a diamond problem. I don't know, guys, if you're aware of what the diamond problem is, but if you're not, you can simply Google it and you will find all the information that you need about it. So in this case, the compiler has sufficient information to make a ruling that this code will not compile as we have seen. So guys, that's it for this video. I hope it was an interesting watch for you, and please don't forget to subscribe.